Welcome to the Environmental Economics for Environmental Sciences course. My name is Francisco Alpizar, and I'm the Chair and Professor of Environmental Economics and Natural Resources at Wageningen University. Joyce and Mohammed have invited me to give this initial lecture. This is the start of the course, and I hope you have a lot of fun and that you learn a lot about the economics that is relevant when you are doing work on environmental sciences. Let me start with telling you why do I think that we need economics, and I would like to start with an example. In Costa Rica, my home country, forest loss has stopped. It has even been reverted. So in 1987, forest loss was as low as 21% of the country. And now it's a staggering 60% of the country. So 60% of Costa Rica is covered in forest. Some people call this the Costa Rican striptease. What happened between 1940 in this initial picture, dark green is forest cover, all the way to 1987, when Costa Rica was more or less stripped of forest. What you see there in darker green is basically only protected areas. But since then, that trend has been reverted. So it has been, Costa Rica has been dressing up again in a forest clothing. Why do you think this is the case? Now, Costa Rica looks like this. This will be the lowlands of the country, and this will be the uplands of the country. Lush tropical vegetation after more or less, 30 years of the forest slowly recovering. There are many reasons, of course, but there is one single common logic to all of them. Some of the reasons are decreasing value of land in agriculture, increasing income from the service sector, cheap imported timber that comes mostly from Chile compared to costly local extraction. Also, tourism is very important for Costa Rica, and people come to Costa Rica to see nature, so there is higher value of having forested land in tourism. Also, since 1996, Costa Rica has been implemented a series of incentives to protect forest conservation, giving more value to your land under forest. So what is the common logic to all of these explanations? That common logic is a reduction in the opportunity cost of forested land. So basically, the opportunity cost of forested land has gone down, and therefore Costa Rica has covered again in forest. So this is very much an economic explanation, and to understand it, we need economics. Now, is there deforestation left? Sure there is. In areas where there are high value crops like pineapple production, and it's there exactly for those opposite reasons. These are remote areas where there is no tourism, so the value of land in tourism is very low, and the value of this land in agriculture is very high, and therefore there is deforestation. So, using the same logic, when the opportunity cost of forested land is high, deforestation continues. This course is a first attempt at understanding how environmental outcomes are affected by economic decisions of households, firms, and governments. This distinction between households, firms, and governments is a very common distinction between actors in the economic landscape, by the way. And also, we are going to explain how economic concepts and tools can be used as part of solving environmental problems. So we're going to somehow explain how the tools from economics can be put to work towards environmental outcomes. Let me start then by explaining what economics is and is not. And I will start with a very old quote from 1935. Economics is the science which studies human behavior as a relationship between ends and scarce means, which have all alternative uses. So what I like about this definition, let me just turn the phone off. What I like about this definition is that it is centered around human behavior. And it puts human behavior as a conflict between limited resources and unlimited needs, which is at the core of what economics is. Economics is about trying to satisfy those needs given limited resources. The second element that I like about this definition is this focus on alternative uses. Every resource has multiple uses, and it could be for multiple groups of society, it could be across generation, it could even include the unborn. So when we make decisions about using natural resources now, either renewable or non-renewable, we are making trade-offs. We are sacrificing something for the sake of something else. And this is at the core of economics. This is another old definition by Paul Samuelson. Economics is the study of how societies use scarce resources to produce valuable commodities and distribute them among different people. What I like about this definition is that it puts the perspective, the focus on the social planner. Ultimately, economics is not how firms organize their inputs to produce more or less carrots or more or less cars. It's about how societies organize themselves to produce the maximum happiness possible for that society given limited resources. Another interesting feature of this definition is that it brings scarcity, the scarce resources, into the forefront. And it is in the scarcity of those resources that we will find their value. Scarce resources have a very high value, and resources that we have a lot, for which there is plenty, they have a lower value. So this link between scarcity of resources and valuable commodities is something that we will discuss throughout this course. And finally, this definition puts the focus on the distribution of happiness, of well-being, of goods and services among different people in society. So economics is not just about producing more and more and more, it's also about how that is distributed in society. Now, this is my definition, a very recent one. Economics is, at its core, the study of how people make choices under conditions of scarcity and the consequences of those choices for society. I like to focus this definition on choices because I think we tend to frequently say, well, this happened just because. But as a fact, everything that happens in our life and in our surrounding, in our society, is because somebody made a choice to have it like that. And therefore, those choices are followed by consequences, and those consequences might affect us. When we make a choice, it might have consequences for us, but it also might have consequences for others in society. Now, of course, the choices we make are a response to the incentives we face. So this sounds almost like psychology, right? We respond to incentives, things we like, whether we face a higher price or a lower price, whether we'll feel happy or unhappy with a given situation. All those incentives shape our decisions and affect, therefore, our choices. Now, when it comes to the consequences of our choices, we tend to define what is good or bad for society, what is optimal, which is optimality means what is best. We tend to judge that using a cost and benefit framework. Now, I have given you a few definitions, including mine, about what economics is. And so far, I've not said anything about economics being markets. It's not about money. It's not about getting rich. It's not about finance, commerce, trade, business. That's not economics. That's a part of economics. That's of course, in economics, some agents will be private firms that are profit maximizer and they care about their profit, their bottom line, as they call it in the business sector. But ultimately, that's not what economics is about. Economics is about societies making decisions and judging our choices by their consequences. Now, another frequent misconception is that economics is hard because it's full of math and statistics. Let me be very clear here. That's complete nonsense. Economics is more philosophical than mathematical. It's a way of understanding human behavior in relation to its surrounding and in relation to the resources that we have available. Yeah, sure, sometimes we use mathematics and we use graphs, but we do this because sometimes the reality is so complex that we need simple tools to understand it. And a nice graph or a little bit of math sometimes helps us understand the situation. Similarly, it's very easy to, work with, describe one little animal and then a second little animal and then a third little animal. But when you're dealing with lots of animals, you need statistics, just like any other natural science will do. So we use statistics precisely to make sense out of lots of data. But we should not be scared of statistics. It's just a tool. These tools should simplify things. They should not make them harder. Now, I believe that economics is often at the core of some of our societal challenges, and it's also typically central to their solutions. So issues like climate change, deforestation, biodiversity loss, plastic pollution, even things like obesity and malnutrition, all of them have at their core humans making choices that have consequences for themselves and for those around them. And whether we are able to change courses in one way or another towards, destruction of the planet or solving these societal challenges will ultimately depend on the incentive structure that we create that will slowly move society towards the preferred outcome, hopefully the survival of our species. But in general, we all respond to tiny little incentives, and economics is about how to shape those incentives in order to produce a world where there is no biodiversity loss or biodiversity loss is minimized, a world where we do not pollute our oceans with tons and tons of plastic, a world in which climate is brought into control and we enjoy, cold winters and beautiful summers. But all for that, economics can be a powerful tool. Let me give you an example of a very simple economic concept with profound insights. Let me go back to this concept of opportunity cost that I used at the beginning of the lecture. So remember that deforestation in Costa Rica was down because the opportunity cost of forested land is low or even negative. But in plain terms, what does this mean? Well, it means that cutting down forests and using the land for agriculture or timber is not really profitable. The profitability of agriculture or timber gives the opportunity cost of land. When the opportunity cost of land under conservation is low, then we have more conservation. Let me give you a formal definition. The cost of something is what you give up. The total cost of something is what you give up to get it. It includes the price. Let's say when you buy this mouse, you need to pay for the mouse, right? But it also includes or should include the opportunity cost. The opportunity cost is defined formally as the net benefits foregone from the next best alternative that was not pursued. I'll give you a few examples. If you decide to take 3 days of unpaid leave to go skiing, for example, then the opportunity cost is 3 days of payment, 3 days of salary that you have forgone. You add the price of the ski pass, for example, and then you have the total cost, which is the price of the ski pass plus 3 days of foregone salaries. If you decide to reforest your land, The opportunity cost is the foregone agricultural income. If you add the reforestation costs for the full cost, then you have a full picture of what it costs to reforest your land. If you decide to study, like you all did, the opportunity cost is the foregone salary from unqualified labor. So if you add tuition fees plus all the salaries that you're not receiving from unqualified labor, then you get to the full cost of studying. And for some people, the tuition fees are not really the obstacle. For some people, the foregone salaries from unqualified labor is the obstacle to education. That's how important the opportunity cost can be. Now, let's put this concept of opportunity cost into practice. Assume that you're hired by the Minister of Environment for a very simple task. The Minister of Environment tells you, we want to create new protected areas, nature is important, and we want to increase the protection of our natural resources. So go find me a few places where to put our money. So now you're tasked with establishing protected areas. Let's use a very simple graph with two axes. The horizontal axis will give you the distance from the city center, say. The farther you go from the city, the more to the right you will be. And the vertical axis gives you the value to society in euros. The higher you get, the more valuable it is for society. This red line gives you the value of land in agriculture. This is how typically the value of land in agriculture will look like. It's very high for agriculture that is very close to the city because it's very close to the markets. But as you move away, as you go far away from the city, the value of land in agriculture goes down up to this point. In this point, the value of land in agriculture becomes 0. So to the right of this point, there is going to be no agriculture. To the left of this point, there is going to be agriculture in the land. So if you choose to put protected area A in here, you end up with a protected area that is actually competing for agricultural space. This protected area competes for land that would otherwise be in agriculture. If you don't put the protected area there, there is going to be no nature. So this protected area and agriculture are competing with each other. Now, of course, if you see this from society's perspective, you will realize that the value to society of this protected area A, is higher than the value to society of agriculture in that area. So, as society, we should keep the protected area there and make sure that in this small area, there is no agriculture. So, since the value to society of the protected area is higher than the value to society of agriculture, and the value of agriculture is larger than 0, this protected area is going to give us effective conservation, true conservation. Now, let's do the same thought exercise for protected area B. Sure, protected area B has positive value to society. Yet, I told you earlier that when the red line crosses the blue line, the distance from the city, the value of agriculture becomes 0. So, to the right of that point, the value of agriculture is negative. So there is going to be no agriculture. And even if protected area B has a big value to society, if you protect that land, you are not going to achieve much additional conservation. So there is no additional conservation. Why? Because that land would not have been converted to agriculture in any case. So protected area A competes with agriculture. So if you don't put the protected area there, agriculture will will be there. You will lose those resources, those natural resources. Protected area B, it might be very valuable for society, but it's not competing with agriculture. There's going to be no agriculture there, irrespective of whether you put the protected area or not. What have we learned from this simple thought exercise? So it's not enough to create a protected area. We must make sure that the area we protect truly delivers additional conservation. If not, you're putting valuable resources into an activity that is not giving you anything additional. In the case of protected area B, that land would have been protected in any case. It would be under conservation in any case, because it's not competing with agriculture. So if you make the effort of creating a protected area there, yes, you will spend some of resources, but you're not going to get additional conservation, which is something that the Minister of Environment actually asks you to give. Additional conservation, increase protection of nature. Now, I know that this is a simple idea, yet it's extraordinarily hard to understand unless we master the concept of opportunity cost of land. Now, a few colleagues studied this problem before, and I give you here Joppa and Fav and Rovalino and Fav as two examples. And they find that, sure, protected areas are not randomly distributed in the landscape, although that will be nice from an ecological perspective, because then you will basically protect different parts of a given landscape. But protected areas are more likely to be established in steep locations where it's very hard to do anything else but have natural cover, far from cities and roads, so where the value of land is very low in any case, so there is no additional conservation from establishing a protected area, and in lands that are less suitable for agriculture, in lands where, for some reasons, agriculture is not very prosperous. So as a result of this, their impact in terms of protecting nature is therefore lower. It's not as high as it could be. Now, the concept of opportunity cost gives us a strategy to correct this. If you want to truly deliver increased conservation, then you need to put protected areas to protect resources that would otherwise, that means in the absence of the protected area, be destroyed for agriculture or another activity. All right, that was the introductory lecture. I hope you enjoy the rest of the course, and thank you for your attention. I leave you with my email address there in case you want to send me a message. Thank you, and I really hope that you enjoy the course. Bye-bye.